Welcome to one and all. This is Dr. Anuradha Devi from Vardhaman College of Engineering. I am from EEE department working as assistant professor. And today's topic is on Thevenin's theorem. The subject is basic electrical engineering. Today we are going to discuss on Thevenin's theorem. Let us start the Thevenin's theorem topic. First we will see why we are using Thevenin's theorem. We have so many theorems and always the Ohm's law, Kirchhoff's laws to analyze our circuits like DC and AC circuits. In the Thevenin's theorem is somewhat very useful, which is very easy method to find out what is the current flowing in the load resistance. At the same time, we can calculate what is the voltage across the load resistance. So, for what type of circuits this theorem is applicable once we see that one. This theorem is only applicable for the linear circuits. What is meant by linear circuits? Linear circuit is nothing but which obeys the Ohm's law. For example, resistance, inductance and capacitors. These are the linear elements. So in the linear elements, whenever the voltage is increasing, the current also increases in the same path. And if you observe the VI characteristics of those elements, it just directly straight and which passes through the origin. Those type of elements must be present in our circuit where we are using to apply the Thevenin's theorem. That is the first point. And second point is, it should be, if you understood that where the theorem can be useful, these theorems can be used in case of power system analysis. Where we are using this theorem is mostly in power system analysis part. So the power system analysis, we are using the Thevenin's theorem, and also to measure the resistance by using Wheatstone bridge also, this Thevenin's theorem will be very useful. Now we will concentrate on what is the statement of the Thevenin's theorem. While giving any statement of Thevenin's theorem, you must concentrate on what are the limitations for the Thevenin's theorem or any theorem. Whatever may be the theorem, if you are giving the statement, start with the limitations. Means the theorem is only applicable for these things only. So I just said that Thevenin's theorem is only applicable for linear circuits. Means while we are giving the statement for the Thevenin's theorem in any linear circuit which consisting of multiple sources and multiple resistances. This is our linear circuit. So it may consist some multiple resistances and also the sources. So this linear circuit which consisting of multiple resistances and sources which is across the load resistance. Here if you observe the resistance is in suffix with Ln, nothing but it is a load resistance. So the total entire circuit can be converted into a Thevenin's equivalent circuit. What is this one? This is our Thevenin's equivalent circuit. Okay, so what is Thevenin equivalent circuit consisting here? A simple voltage source, only single voltage source which is in series with the Thevenin's resistance and which is connected across this load resistance. What is VTH ma? Here VTH is nothing but the Thevenin's voltage and RTH is nothing but the Thevenin's resistance. The suffix VTH gives you Thevenin's voltage, and also we can call this one as open circuit voltage. Another name for Thevenin's voltage is what? Open circuit voltage. And what is another term we have here is RTH, nothing but our Thevenin's resistance. Thevenin's resistance. So RL you know, what is that? RL is nothing but load resistance where actually we want to find out the current in a particular resistance. So in the total circuit, we want to calculate the current in any resistor, then we can use the Thevenin's theorem. So the statement for the Thevenin's theorem is nothing but in any linear circuit which consisting of multiple resistors and sources can be converted into a simple Thevenin's equivalent circuit. That simple Thevenin equivalent circuit consists of a single voltage source in series with a resistance across the load resistance terminals. Already we understood that Thevenin's voltage is nothing but our open circuit voltage, and Thevenin's resistance is the equivalent Thevenin's resistance, and RL is nothing but the load resistance where you want to calculate the current and the voltage in a particular circuit. So now we would find how to calculate what is VTH value, RTH value, because to convert any linear circuit into a Thevenin's equivalent circuit, we must need what is the value of VTH, that is the first thing, and second one is what is the value of RTH. If you know these two values, automatically we can complete our Thevenin's equivalent circuit, because already we know what is the value of load resistance where you want to calculate the current. So from the problem itself you can understood what is the value of RL. RL is nothing but in which resistor you want to calculate the current, or it may be the voltage. Okay, so if you know the load resistance, what are the unknown things here from the circuit? Only VTH value and RTH value. So to find out VTH and RTH, some steps will be there. We will follow those steps. According to that, we will calculate what is VTH, that is open circuit voltage, and what is RTH, that is Thevenin's resistance. Once you know these two values, you can easily build up what is Thevenin's equivalent circuit. Okay. Once you got Thevenin's equivalent circuit, next we will see how to calculate the current in the particular resistance or the voltage in the resistance. So first we will see how to calculate VTH value and the RTH value. Let's continue. As discussed earlier, so we have to calculate first what is the VTH value, and second one is what is the RTH value. So here what is VTH? I told VTH is nothing but the Thevenin's voltage or the open circuit voltage. So these are the steps required to calculate the VTH value. So the first one is what? Remove the load resistor. RL is already you know the value from the circuit where you want to calculate the current. So remove that load resistance which is given in the circuit. And the second one is calculate the open circuit voltage. I already discussed with you the Thevenin's voltage is nothing but the open circuit voltage. So we have to calculate, when you are remove the load resistance, the circuit is represented with two open circuited terminals. Now you have to calculate what is the voltage across that two terminals. That will become your VTH value. And the second thing is very important one. This is your RTH value. So RTH is nothing but what? Thevenin's resistance. For to calculate Thevenin's resistance, these are the steps you have to follow. The first step is remove the load resistance as usual what you have done in your Thevenin's voltage calculation. Just remove the load resistance and replace all the sources with their equivalent resistances. Here what are the sources will you get in the network? Nothing but your voltage sources and the current sources. So replace all the sources. Wherever voltage sources are present, you just replace it with this short circuit. So next, if you have any current sources, so if any current sources are present, replace it with the open circuit. So short circuit the voltage sources and open circuit the current sources for the second step. So replacing all the sources with their equivalent resistances. Next we will calculate the Thevenin's resistance by using the network reduction techniques, nothing but by using series combination of resistances or parallel combination of resistances. By using these combinations, we will calculate what is the RTH value. So the steps required to calculate VTH and RTH are nothing but, first to calculate VTH means you remove the load resistance. Once you remove the load resistance, the resistance removing nothing but you will get two open circuited terminals across that two open circuited terminals. Calculate what is the voltage, that will become your VTH. And second, nothing but again remove the load resistance and replace all the voltage and current sources with their equivalent resistances. Next, calculate the Thevenin's resistance by using the series and parallel network reduction techniques. Okay, so just I will show you how to calculate this Thevenin's voltage and Thevenin's resistance by using some numerical examples and some models. What are the steps involved in calculating Thevenin's voltage and the Thevenin's resistance? Then you will get clear idea about this Thevenin's theorem. Okay, here I am considering this model to calculate, to apply the Thevenin's theorem. And if you observe in the entire circuit, we have 4 resistances, nothing but R1, R2, R3, which is nothing but a T network, and which is connected across the load resistance RL, and which is having some source voltage. Now we are considering one example, a model, to show how to calculate the Thevenin's, how to apply the Thevenin's theorem and how to calculate the current in the load resistance. So if you observe here we have a T network. The resistances are R1 and R2, R3, which are connected in a T circuit. And in series with, we have one load resistance where you have to calculate the current. And one source voltage here I have taken, which is represented with V suffix S, that is the source voltage. Okay. So here I am having one single voltage source and a T network which is connected across the load resistance. So where you want to calculate the current? In the load resistance. So that I will take it as IL, where I want to calculate the current. Okay. So we have already discussed that to build up any circuit into a Thevenin's equivalent circuit, we must require first 2 things. What is that one? First one is Thevenin's voltage and second one is R Thevenin. If you know these 2, we can easily calculate the current in the load resistance. So first we will see what is VTH. So what are the steps involved in calculating VTH value? The first step is nothing but we have to remove the load resistance. And when you remove the load resistance, you will observe that 2 open circuited terminals and calculate what is the voltage across that load resistance. Okay. Now first I will remove the load resistance and I will again redraw my circuit how it would be once I remove my RL value. Okay. Just observe. So here I am removing the load resistance to calculate the Thevenin's voltage. So this is actual circuit. And just remove the load resistance, this RL resistance, and you will get 2 open circuited terminals. So now we will calculate the voltage across these 2 open circuited terminals. Okay. So if you observe, this is the voltage source Vs and these are the resistance R1, R2 and R3. These are the 3 resistances we have. So when source voltage is applied, current is flowing from the positive terminal of our source and it enters into R1. Is there any chance our current is entering into resistance R2? No, because it is already open circuited. So the current directly comes into the resistor R3. So whatever the current flowing from the Vs source voltage is entering into R1 and then R3. There is no chance to get the current in the resistance R2. If the current is 0 at the resistance R2, what is the voltage across R2? You can consider it as 0. So once the voltage is 0, it definitely that VTH is nothing but the voltage across this open circuited terminals. VTH will become like the voltage across R3. Yes or no? So because the voltage across R2 is 0, so whatever the voltage present here across the open circuited terminals is directly equal to the voltage across R3. So now to calculate voltage across R3, easily we can apply the mesh analysis or nothing but you can apply the Kirchhoff's voltage law. So in this Kirchhoff's voltage law, the algebraic sum of the voltages must be equal to 0. So in this mesh, the algebraic sum of the voltages equal to 0 means you can take it as what is the current flowing in the resistor I will be calculated first. So that is nothing but what is the current I will become here. From the Ohm's law, it is nothing but voltage divided by the total resistance. What is the voltage we have? The single voltage source, that is Vs, and what is the resistance from this entire circuit? The 2 resistances R1 and R3 are connected in series, so you will get it as Vs divided by R1 plus R3. Now you got the current which is flowing in this mesh. Vs, R1 and R3, the current is flowing is nothing but Vs divided by R1 plus R3. Once you got I value, we can easily identify what is the voltage across resistance R3, which is nothing but voltage across resistance R3. So nothing but from Ohm's law, you know already the voltage across any resistance is nothing but current multiplied by that resistor. So what is the resistance is there? So to calculate the voltage across R3, you have to multiply the current with resistance R3. Okay, this will become your VTH. What is VTH, ma? VTH is nothing but the open circuit voltage across the terminals, which is exactly equal to the voltage across R3. So that I have calculated by using the Ohm's law. So I is equal to total voltage by total resistance. What is the total voltage you have? Vs divided by resistance is nothing but R1 plus R3, and you got the total voltage V3 is nothing but from Ohm's law current multiplied by the resistance. The current multiplied by resistance, you will calculate what is VTH. So we have completed half of our Thevenin's theorem equivalent circuit. How to build up a Thevenin's equivalent circuit? Nothing but first you have to remove the load resistance. Then across the two open circuited terminals, calculate what is the voltage. That we have calculated just by applying the KVL and also the Ohm's law. We will get the voltage across open circuited terminals, that is VTH. Okay, now once you completed VTH value, we will see the second part of that, nothing but RTH. That is Thevenin's resistance. What are the steps involved in Thevenin's resistance? So as usual in Thevenin's voltage, we have first remove the load resistance. So once you remove the load resistance in the earlier circuit, you will you also represent the sources with their equivalent resistances. We have only one voltage source, so just short circuit that voltage source, and you will have the three resistances which are connected in T, and remove the load resistance. Now your circuit will be like this. Yes or no? This is R1, R2 and R3. From these open circuited terminals, we will calculate what is the RTH value. Okay, now if you observe this entire circuit, the resistances R1 and R3 are connected in parallel, which is connected in series with resistance R2. So what is our RTH value? RTH is nothing but R1 is in parallel with R3, which is again in series with R2. So by using network reduction techniques, we can calculate what is the RTH value, right? So you know already VTH, you know already RTH. Now we can exactly represent our entire circuit into a Thevenin's equivalent circuit. What is the Thevenin's equivalent circuit? Nothing but one single voltage source which is in series with RTH, and it is connected across the load resistance RL. This is RL, RTH, and this is our VTH. Now we have to calculate IL value. Yes, so this is our Thevenin's equivalent circuit. So we will see how to calculate the IL value in the load resistance RL. How we will calculate? So if you observe, your entire circuit is having two resistances which are connected in series, and you are having one single voltage source. So from the Ohm's law, if I want to calculate current, nothing but voltage divided by resistance. What is the voltage you have in your circuit? Only single voltage source, that is Thevenin's voltage. What is the resistance you are having? Two resistors are there which are connected in series. So it will become RTH plus RL because they are connected in series. So now by using this formula, that is IL is nothing but VTH divided by RTH plus RL. So this is our current value in the load resistance. So these are the steps involved in calculating the current in any resistance. So in the entire circuit, you can calculate the current in any resistor. That resistor will become our load resistance. Okay, here I have taken one T network which is connected in series with the load resistor, and I used to calculate what is VTH, what is RTH, and finally I got the load current formula as VTH divided by RTH plus RL. This is our formula to calculate the load current value. Okay, once you calculate load current, can't we calculate what is the voltage across that resistance? Nothing but you can use here Ohm's law. So you know already the current value and already you know the load resistance value. Just apply Ohm's law to calculate VL. The voltage is nothing but from Ohm's law, current multiplied by resistance. Current multiplied by the resistance. So what is the current you have? Okay, so now we have calculated IL value and we will see how to calculate the load voltage. Okay, so to calculate load voltage we can use again the Ohm's law. Voltage is nothing but current multiplied by resistance. The current is again IL, that is load current, multiplied by the load resistance, you will get the load voltage. So these are the two formulas we can use to calculate the current and voltage in the load resistance for using the Thevenin's theorem problems. Okay, so this is the model I have taken by using Thevenin's theorem to calculate the load current and the load voltage. Just we will see a simple example, simple numerical example, so that you can get clear idea how to do any problem by using Thevenin's theorem. Okay, so now we will see a simple numerical example to solve our Thevenin's problem. So if you observe, again same, I have taken one T network which is connected in series with a load resistance 5 kilo ohms, and here we are having one single voltage source, that is 48 volts. So I want to calculate in this entire circuit the current in the 5 kilo ohms. So now what is our load resistance value? RL will become what? It will become 5 kilo ohms. Yes or no? So in the entire circuit, I want to calculate current in 5 kilo ohms. So I will take RL value, that is the load resistance now will become 5 kilo ohms. Okay. Now we have to build up this, represent this entire circuit into a Thevenin's equivalent circuit. So to get the Thevenin's equivalent circuit, we need to calculate, first one is VTH, after that RTH. So we will start calculation of VTH value. So to calculate VTH, what are the steps we will follow? First remove the load resistor and you will get the open circuited terminals. Now calculate what is the voltage across the open circuited terminals. So this is our circuit once you remove the load resistance. Yes, here you have two open circuited terminals and we will calculate the VTH across these two open circuited terminals. The values are 8 kilo ohms, 12 kilo ohms, 4 kilo ohms, and voltage is 48 volts. Okay, so now what is the VTH value, open circuit voltage? Because the current which is produced from the source is directly enters into 12 kilo ohms, after that it comes into directly to the 4 kilo ohms resistor. So the current in the 8 kilo ohm resistor will become 0. Why? Because you are having the open circuited terminals, no? So there is no current in 8 kilo ohms and the voltage will become across this 8 kilo ohms will become 0. So now what is VTH? Is this directly equal to, so the VTH is now directly equal to 4 kilo ohms. Voltage across the 4 kilo ohms is nothing but your Thevenin's voltage. So how we will calculate Thevenin's voltage or the across 4 kilo ohms, what is the voltage? Again same, algebraic sum of the voltages in a closed path equal to 0. Apply the KVL and you will get what is the value of the current in this mesh. Once you know the current, multiply that the resistance, you will get the voltage. Okay, so first we will calculate what is the current flowing in this mesh. Just nothing but I is equal to, what is the formula? I is equal to V divided by R. What is the voltage we have? 48 volts divided by, what is the total resistance of this mesh? These two resistance 12 kilo ohms and 4 kilo ohms are connected in series. So add these two resistors. In series means R1 plus R2. So you will get 48 by 16. So the current will become 3, is it in kilo ohms? So the current will become in milliamperes. So I will become 3 milliamperes. Okay. We got only the current in the mesh, but we have to find what is the voltage across the 4 kilo ohms. That is our VTH value. So VTH is nothing but voltage across the 4 kilo ohms. What is the voltage formula from Ohm's law? Current multiplied by that resistance. What is the resistance? We have 4 kilo ohms. So it will become 3 into 4. So the voltage is nothing but 12 volts. What is VTH we got? 12 volts. Okay. So we have completed what is the VTH or the Thevenin's voltage for this circuit. Now the second part is nothing but calculation of the RTH value. So to calculate RTH value, the first step is again remove the load resistance, and the second step is replace all the voltage sources with short circuit, and current sources, if they are, you have to represent with open circuit. But in our problem we have only one voltage source, so short circuit that one and your circuit will become like this. This is our 12 kilo ohms, 4 kilo ohms and 8 kilo ohms. To calculate the Thevenin's resistance, the first step is remove the load resistor and represent the voltage source with short circuit. Here I have short circuited the voltage source and the circuit will become like this. Now calculate the Thevenin's resistance by using the network reduction techniques. So what is RTH value now? It would become the 12 kilo ohms and the 4 kilo ohms are connected, both are in parallel, which is again connected in series with the 8 kilo ohms. So 12 is in parallel with 4, which is again connected in series with 8 kilo ohms. What is the formula for the two resistances are connected in parallel? R1 is in parallel with R2 is nothing but R2 divided by R1 plus R2. So I am applying that formula. I will get 12 into 4 divided by 12 plus 4, which is in series with 8. So you will get 48 divided by 16 is plus 8. Nothing but 3 plus 8. You will get 11 kilo ohms. Please take care about the units while calculating. So the Thevenin's resistance, I got the value as 11 kilo ohms. So previously, if you know the VTH value, you have observed that the value is nothing but, if you observe, VTH value is 12 volts and next our RTH value is 11 kilo ohms. So if you know VTH and RTH, and already you know the value of load resistance, that is 5 kilo ohms. Now we can draw the Thevenin's equivalent circuit. That is nothing but first VTH, the value is how much we got? 12 volts, which is in series with the Thevenin's resistance, and that value is 11 kilo ohms, which is in series with the load resistance, the value is 5 kilo ohms. Now this would become our Thevenin's equivalent circuit. Okay. So we have simplified that complex circuit into a Thevenin's equivalent circuit. Now this circuit is easy to calculate the current. Yes. So we are having one single voltage source and two resistances which are connected in series. Can't we calculate what is the load current? Formula is already you know. What is that formula? VTH divided by RTH plus RL. What is VTH here? The value is 12 volts. Substitute that one, 12 divided by 11 plus 5. So here I will get 12 divided by 16. That is 0.75 amperes. What is the value we will get? IL is nothing but 0.75 amperes. So this is our final answer. The load current in the load resistance. So once you will get load current, just by using the Ohm's law, we will calculate what is the VL value. Nothing but current multiplied by the resistance value 5 kilo ohms. You will get the voltage across the load resistance. So this is the way to calculate the current in the load resistance or voltage across the load resistance by using the Thevenin's theorem. So here different theorems are there for the electric circuit analysis. This is the one theorem we are using. This is to calculate the current in any resistance or voltage in any resistance. Okay. The formula to calculate the load current is VTH divided by RTH plus RL. So VTH is nothing but the open circuit voltage, and RTH is our Thevenin's resistance, and RL is the load resistance. So just by calculating the two steps, nothing but what is VTH value, what is RTH value, we can represent our complex circuit into a simple circuit, which is having one single voltage source with two resistors connected in series. By applying this formula, you can calculate this value. So just by doing so many problems in this way, you can get clear idea about how to apply the Thevenin's theorem, which is very, very useful in circuit analysis. So what are the limitations? I said this is only suitable for the linear circuits, and if you observe, the power transmission or the power value in the Thevenin's theorem is not equal to what is the power calculation in the real circuits. So that is those are the two limitations we have, and we can use this Thevenin's theorem in power system analysis and as well as in resistance calculation by using the Wheatstone bridge. So these are the two applications we can give from the Thevenin's theorem. Thank you for this.